DPU is known as the third main chip in data center. What makes DPU? From October 2021 to now, the Institute of Computing, Chinese Academy of Sciences, ICAS, has released a white paper on dedicated data processor, DPU, technology, and dedicated data processor, DPU, performance benchmark evaluation methodology and implementation for the whole industry, which explain in a more comprehensive way why DPU is defined as a disruptive technology for data center development. In the DPU performance benchmarking white paper, the evaluation and implementation methods of DPU in 4 areas of network, storage, computing and information security are described, which are the 4 areas where DPU unleashes its potential, while they happen to be the key aspects of data centers. Therefore, DPU, CPU, and GPU are called the troika in the era of arithmetic economy, and DPU has become the third main chip in the data center field. In addition, smart driving, data communication, network security, etc. are also target application areas for DPUs. According to the estimation of Sadie.com, the global DPU market size will exceed $10 billion starting from 2023, with subsequent annual growth rate of over 50%. That's why Nvidia CEO Jensen Huang highlighted when releasing the company's first DPU product, this is just the beginning. Currently, not only are industry giants such as Nvidia eyeing the DPU track, but startups such as Wellspring Microelectronics are also standing out, showing extraordinary technical strength and gaining industry recognition for their products. What is DPU? To know why DPU is hot, we must first figure out what DPU actually is. DPU is called Data Processing Unit in English, which is directly translated as Data Processing Unit, also known as Data Center Processor by some practitioners. DPU is data-centric, and its core role is to do data acceleration to help the system solve the load that CPU processing is inefficient and GPU cannot handle. According to the DPU technical white paper, the data processed by DPU is different from the signals processed by traditional DSPs, baseband processors, and other processors, as well as the graphic image data processed by GPUs. The data processed by DPU is closer to the underlying architecture and digitized information, especially all kinds of time series and structured data, such as large structured tables, packets in network streams, large amounts of text, etc. DPU has great potential. It is not difficult to find that DPU is proposed to solve the bottleneck of data center development as the first starting point, and is the biggest beneficiary of servers for data center towards heterogeneous computing. With the booming data center market, DPU has great potential in this field. Taking the Chinese market as an example, the first wave of data centers kicked off in 2014 to 2015, mainly serving the rapidly developing internet at that time, when many data exchanges emerged in China. In terms of specific features, the first wave of data centers was computationally focused. However, the CPU as the main arithmetic platform soon became a bottleneck, and there was a general waste of 20% to 30% of arithmetic resources in resource management of CPUs, which brought about a sense of powerlessness in arithmetic enhancement. The second wave of data centers started in 2020, which is also known as the year of DPU, and the most obvious change is that data centers no longer emphasize the concept of computing center and arithmetic center, but return to the essence of data-centric. In this process, both cloud and application algorithms are becoming more and more diverse, and while improving data processing efficiency is still the main goal, reducing the load on CPUs to enhance system scheduling capabilities is also a major direction. The shift from compute-centric to data-centric is a huge conceptual shift that has allowed DPUs to stand out from the crowd of coprocessors. As a dedicated engine for data processing, the future enrichment of DPU product types will enable CPUs to return to what they are good at: coordinating global and task scheduling, releasing CPU computing power to upper layer applications, and DPUs will become the new system gateway, storage portal, algorithm acceleration sandbox, and security engine. Of course, DPUs need to overcome some challenges to realize their potential in the data center space. First, at the hardware level, DPU products need to be rich enough, as mentioned above, to fully offload CPUs in the 4 dimensions of network, storage, computing and information security, while DPU products from different vendors need to follow common standards and reflect total cost of ownership advantages in the overall solution. At the software level, current CPU and GPU applications in data centers have standard software framework, realizing software and hardware decoupling, which is also a long-term and challenging task after DPU is added. As mentioned above, the end-use scenario of DPU is by no means only in the data center, but also in the fields of smart driving, data communication, network security, etc. DPU has broad application prospects. For example, in the field of communication, the DPU-based implementation of network function virtualization can be applied to 5G edge computing UPF to enhance the high-speed and large bandwidth capability of 5G communication in vertical industries. In the field of network security, DPU can help create a hardware root of trust and can achieve isolation in a completely offloaded manner. In the field of cybersecurity, DPU can help create a hardware root of trust and isolate it from the host operating system in a completely offloaded manner, so that users are protected from hackers.